10 train lines.
I don't know how many. No, I mean if I don't know.
We need to get tickets for Dynamic Earth, and look, the sun keeps peeking out, so hopefully it'll be a nice day. Relatively stress-free, loads of spaces to sit. So that's us on the train, less busy than last time, and that's us heading to Glasgow. Not Glasgow, Edinburgh. the time machine.
Greetings, fellow time travellers. Let's go back to the beginning of time itself. Would you believe it? The first hominids only 2 million years ago. And dinosaurs, whoa, around on Earth for 165 million years. Some strange creatures walked the land 380 million years ago. 580 million years ago, there was an explosion of different life forms in the seas. And an astonishing 3.5 billion years ago, it was only simple bacterial life. The early Earth was bombarded by meteorites around 4 billion years ago. Our planet was born from the material left over from the formation of our star, the Sun, all of 4.54 billion years ago. And as galaxies converge, we emerged 13.8 billion years ago at the beginning of time.
From here, you're going to see the beginning of our universe. So come right on down to the front here.
Hello, small life form.
Take a look out of the windows.
My name is Odie.
And I'll pass you on to your captain.
Okay.
All systems checked. Warp engine primed. Ready to engage time dilator. Singularity locked in target screen. 5, 4, 3, 2, 1. Engage. Universe age 0 seconds.
Welcome, time travelers. You are about to witness the birth of the universe. All space, time, energy, and matter in a tiny, dense, immensely hot point. The point is not in anything, it is everything. This is the Big Bang.
Universe age 3 minutes.
The universe is expanding rapidly and is incredibly hot and dense. The first matter is beginning to form.
Universe age 380,000 years.
Hydrogen nuclei are combining with electrons. The first complete atoms have formed, and light is starting to travel freely throughout the universe.
Universe age 200 million years. Switching screen to 21 centimeter wavelength.
The universe continues to expand and cool. In the blackness of space, gravity is forcing the hydrogen to collect and concentrate into massive swirling clouds, the first galaxies. Inside these young galaxies, something is happening that will light up the universe.
Universe age 1 billion years.
Pockets of hydrogen gas are collecting together. As their mass increases, they attract more and more hydrogen to form supermassive clouds of hydrogen gas. At a critical tipping point, the pressure caused by gravity forces the hydrogen nuclei at the core to fuse with their neighbors. The energy released creates a chain reaction through the cloud, and a star is born. Across the universe, in billions of galaxies, trillions of stars are igniting. These stars eventually reach a balance between the force of the nuclear reactions in the core pushing outwards and the force of gravity holding the star together. As the stars burn their hydrogen in a process called fusion, they create new elements like helium and oxygen. The largest of these early stars have very short lifespans, burning through their hydrogen in just a few million years. When the hydrogen runs out, the internal pressure drops and gravity takes over, collapsing the core. The collapsing material then rebounds in a giant explosion known as a supernova.
Gamma radiation warning. Closing shields. Unsafe levels for humans. Moving ship to safe distance. Universe age 3 billion years.
A supernova releases as much energy as your sun will produce in its entire lifetime. All the heavier elements in the universe, like iron, copper, and gold, are forged in these catastrophic events. Each explosion enriches a galaxy with a soup of new elements. Over time, they form clouds called nebulae. In a spiral arm of one galaxy called the Milky Way, something is growing deep inside a nebula.
New timeline, solar system, universe age 9.2 billion years.
A disk of gas and dust has formed. At the center, a dense cloud of hydrogen is about to ignite into a star. You will one day call the Sun. In a rotating disk that surrounds the newborn Sun, material is starting to clump together to form blocks of rock and ice. Close into the young Sun, rocky materials are plentiful. Here, the planets Mercury, Venus, Mars, and your own Earth are forming.
Universe age 9.3 billion years. Earth age 0 years. New timeline.
Mountain-sized blocks of rock and ice continue to rain down on Earth for millions of years. They carry the water that will eventually form the Earth's oceans.
Prepare for descent to planet surface. Closing shields. Braking sequence initiated. Time jump car locked and correct. Altitude 10,000. 5, 4, 3, 2, 1. Landing confirmed. Earth age 2 billion years.
As the Earth cools, moisture in its atmosphere condenses, and it begins to rain. Every water molecule contains 2 hydrogen atoms, each formed when the universe was young. There is also one oxygen atom, forged in the heart of a star. Water is the molecule on which all life on Earth depends. The Earth is now cool enough for you to leave the ship.
Man, that saber-tooth tiger is so cool. Don't look at his, why are you looking at his butt? I mean, look, there's her brain. Maybe that's what her brain looks like. Oh wow, 7.9 billion. It's weird, it'll be going up and down at the same time.
Oh, I went down there.
That's so interesting. Ibs, keep going.
Come see that?
Wow, all the lights came on when you did that. What do you do, push it?
A sharkfish, whale airborne, and squid beak. Ooh.
That's what it looks like. Wait, up here. Have you seen in the microscope? What was it?
Oh, a specimen from the deep. That's a whale. Sharks are one of the major causes of blood poisoning in the ocean.
It's amazing, isn't it?
Can you open it?
I did. It's like a wee tiny wee beastie. Oh, so it's as if you're underwater. Very good. Have a look at the surface temperature 15 degrees and the depth temperature is 2 degrees. Oh, so it's a robot that they put in. Temperature, guys. Push. Oh my good. Push.
Scotland and northern Europe warm could be pushed south, leading to colder temperatures in Scotland rather than warmer ones. There is still much to discover about the extraordinary worlds we call the polar regions. There's still much that they can tell us about our planet.
It says, watch out for milk ice.
Wow. Look down. Abby, can I take a picture
The
over here?
polar
Stand here?
regions are places of spectacular extremes, with winters of perpetual darkness and summers of constant sunlight. These are the coldest, harshest places on Earth, but still life finds extraordinary ways to survive here.
Just like
And
a
fun.
hologram maybe?
Ah, it's gonna bite our feet. We just have to pretend that it's like scary. Oh man, you could just sit here when it's really hot.
The Arctic stretches across the top of the world, a great flat land.
Remember?
Very long.
Man, this is the, so it's showing you the temperature now.
When winter sets in, the bitterly cold temperatures freeze the ocean surface. Wind and ocean currents keep this high ice on the move throughout the year.
Open the door, baby, push.
The darkness of the Arctic winter is only relieved by a very special event.
That's our Arctic base. So this is our basic area where you catch the light always to the west after the rainforest. Next
Wow.
is under 6 minutes. So you're welcome to wait if you're not looking around, or you're welcome to wait back to where the other.
No, perfect. I mean, we're gonna go to the rainforest now. Oh, is that rainforest skin? I mean, rainforest? Reindeer? I know. Poor reindeers. Oh.
You can see it. You can see it.
Look at that, they're so beautiful. Why do people do that? Sometimes they'll kill them just to take their head off and like display them, like stuff them.
Cold at altitude. Animals here are also excellent climbers to cope with a rocky environment.
None of it's falling in.
I went forward. That's some leaf.
Remember, I was here. That's exactly when he said, "Where is it faking us?"
I was getting freaked out.
It's just because I thought you said something else, but then I replied that I was like,
I never mind.
Landing next to an active volcano. So if the volcano does erupt, the ground gets a little bit shaky. There are a few flashing lights, but do not worry, there are volcanoes for doing
The Earth is a planet of oceans and continents, though 180 million years ago, unrecognizable to us. Oxygen in the atmosphere has allowed complex forms of life to evolve. The surface is still changing, and the continents are slowly moving. Within the planet, a heat engine of nuclear decay causes the hot rock of the enclosing mantle to flow. It is that energy that moves the surface crust and the continents upon it. Like a giant jigsaw puzzle, that crust is split into numerous huge slabs and plates. Each plate moving at about the speed of our fingernails. Among these primeval land masses, the outlines of the continents of today cannot be recognized. But some lands we well know, such as Scotland, are, even at this time, adrift on the planet's surface, moving across different latitudes and through different climates, journeys that are being recorded in the rocks that are formed on the way. Mountain ranges are thrown up where two plates, each carrying a continent, collide. Where rift valleys open on land, oceans may eventually be created. Deep in mid-ocean, wherever two plates are being pulled apart, volcanic lava erupts from the Earth's mantle. Hot springs smoke, and lava solidifies into ridges of new crust along the edge of each plate. In the mid-Atlantic, where the European plate is pulling apart from the North American plate, the submarine ridge has risen above water and is forming the volcanic island of Iceland.
eruption is just like those along a submerged bridge. In this fire fountain, the fluid lava is spraying from a fissure. Similar eruptions created the basalt rock of Staffa and other volcanic landscapes of western Scotland when the Atlantic Ocean began to form and widen. Melting takes place, and the volcanism is much more violent. The undersea plate Chilbredi is passing
Hold on tight on it.
1,000-kilometre crossfire. The oceanic crust is about to be pulled by its own weight into the seething heat of the Earth's mantle of rock. The jarring plates trigger earthquakes. Pressure increases 15,000 times. Seawater in the crust at 1,000 degrees Celsius causes mantle rock to melt, rise, and explode at the surface. Eruptions from a chain of dangerously violent volcanoes on the coast. They emit vast quantities of ash. Clouds of superheated dust and gas at 500 degrees. Is both destructive and creative. It is a driving force of the shaping and reshaping of this restless earth. Land that had been born in fire became buried by persistent snows. The increasing weight of this layer of blankets not only trapped air from the atmosphere of past times, but compressed the snow into ice. Vast glaciers formed. A million years ago, all Scotland bare, ponderous, frozen, and slowly moving land. As the ice sheets thickened and spread, they also grew in weight and power. Flowing at the pace of the hour hand of a clock, a glacier reshapes the surface of the land beneath. A yawning crevasse exposes the structure of a glacier. The dark layers hold rock fragments, debris torn from the ground.
Are you flying?
Rocks that have become the teeth of the glacier, rasping at the land, fashioning its contours with immense power.
Feel like I'm flying.
A gigantic natural sand machine, the glacier scars and carves deep valleys, leaving mountain ridges behind as signposts of its passing. As though hungry for rock, these great tongues of ice lick the valleys into shape, ripping rocks from the side walls and engulfing them in ice. Held at the glacier's edges, this huge mass of hidden two smaller glaciers merge, debris gathering along their edges forms a rocky ribbon in the middle of the new, bigger glacier. At the tip of a glacier, where its leading edge finally melts, huge ramparts of debris build up, heaps of eroded rocks liberated from the ice. Trapped behind such ridges, meltwater may form a lake. The retreat and advance of glaciers during successive ice ages has left a crumpled blanket of debris across many landscapes. When ice first relinquishes its grip, the ground revealed has been roughened by the glacier's work, leaving deep valleys bounded by rocky scree and cradling mountain lakes. Now running water carves the rock, a further powerful erosive force. Water can move mountains, wearing them down, sifting and salting rock fragments by seconds. Fine rains round out within the glacier, melt out of the ice, turning glacial rivers milky as they start their journey to the sea.
Yeah, I feel a bit dizzy.
Shaped by glaciers which melted 10,000 years ago, the Scottish landscape has been softened by time, matured by the weathering of the rock and the growth of plants. But the arêtes and pinnacles of these majestic mountains are unmistakable creations of an age of ice. Now, that debris continues to be weathered and transported away to the sea as a natural cargo in streams and rivers. Landscapes are always changing. Ice, wind, and water are relentlessly at work.
Hey, how you finding?
Polished Highland rocks, scarred by a moving glacier, are dramatic evidence of such timeless forces. A river, heavily laden with sand, silt and gravel, creates a new landscape of floodplains, marshes and mudflats. At last the material of mountains washes into the sea. Currents and tides shape and reshape the sediments into beaches, and off the finer grains offshore into deeper waters where they settle and compress, turning slowly into rock, from which mountains may once more be built.